All right, we are with Oana Platon, and we met you during the tour.
Yes.
And we had a brief conversation. And so we want to come and talk to you today a little bit deeper about what you've been working on. So tell us about yourself and kind of the things that you work on in Service Fabric.
I've been in Service Fabric for a long time. Been here ever since the team had below one-digit number team. So I think I was like the 10th or something developer in the team.
Wow.
I think my whole entire life is Service Fabric. I've been here so long that I forgot what I've done before. I started in Service Fabric. Actually, you talked to Sumukh last time.
Yes.
I wrote the B1 replicator, so the native part that actually sends bits on the wire.
Awesome.
So that it changed a lot since then. It went through a lot of hands since I gave it up when I moved to something else. But that's how I started.
Great.
And then I worked a little bit on naming, then I wrote a health manager, and then a little bit of cluster manager, and now I own the management area with a lot of work lately on image store.
Excellent. So the management area is the chiclet that spans the entire range of our core subsystems?
Yes, it basically
layer.
has the cluster manager, the health manager, the image store. Basically, you have the bits, you need to deploy them to the packet, to the cluster. So how do you do that? That's the image store part. And then you need to create an application. How do you do that? How you deploy? How do you provision your application type? How do you span up your applications? How do you upgrade? And this kind of flow.
Cool. So just kind of randomly, did you study computer science?
Yes.
Okay.
I went to Romania and Politehnica University of Bucharest.
Nice.
Yeah.
And your first job was at Microsoft?
Yes.
In Service Fabric?
No, I was in the ASP.NET team for a while.
Nice.
I was in the stress team.
Cool.
Yeah.
All right, so today we're going to focus on Health Manager.
Yep.
In that part of the infrastructure, management infrastructure.
Yep.
So what does a Health Manager do?
So usually when people think about health in distributed service, they think about, hey, is my process alive? Is my machine alive? And it's not that.
Okay.
We actually introduced the health subsystem because we needed it for upgrades. We have applications and we wanted to upgrade and we wanted to be able to detect when something goes bad and roll back automatically.
Okay.
So health is basically the answer to this. Is everything okay? Is my application still healthy? And if not, a CM will roll back to last known version. So the way health does it is based on the philosophy that system components know locally what is wrong or what goes well, and they report based on their local view. And then the health gets all this information and is able to evaluate, to get a global view of the application or cluster or whatever else we're interested in. So basically, it has a hierarchy of entities. We have 7 types of entities, and there are system components, watchdogs, even services themselves that can report health, and then health subsystem aggregates this information and is able to evaluate and tell you if it's anything wrong. The health subsystem is a system service. It's actually inside the cluster manager. So if you look in SFX, you have that view with you have the applications, and then you have your apps based on app types, and then you have the system. Inside the system application, you'll have CM, which is Fabric System Cluster Manager Service. Okay. And HM lives inside this guy. Okay, so they're actually separate services. They're written as they can run on a different nodes, but because HM was used basically by CM during upgrades, we wanted the low latency between them. So we decided to put them together. Okay. So Health Manager is a stateful system service, and basically in any cluster you'll have one of it, and it stores all the data it receives about the entities in the cluster and is able to evaluate them. And the entities it has, like I said, the 7 types. You will have the cluster entity. Okay, so we have the cluster entity, and then during this under this cluster you will have nodes, and then you have applications, and the applications will have services, partitions, and replicas. On the other side, these applications are deployed on a node, so we have deployed application. And under deployed application, we have deployed service package. So all of these health entities are mirrors of the entities that are actually in the cluster. And each of the entity has a system component that's the authority that knows about that. And if that entity does not have the system authority report, it will be evaluated as error because somebody else reported, but the authority doesn't know something is wrong. So this hierarchy basically gives you the children and the parents for these entities. And there's a special relationship between nodes because a replica is deployed on a node. If the node goes down, there's no way a replica can be there, right? So then there's this relationship between nodes, deployed service packages, and deployed and the replicas. And when the node goes down, HM knows to clean up all the entities that run on it. So we do some magic cleaning up so we don't leak entities inside HM. So the way we build this hierarchy is based on attributes. So each system component, basically the authority system component in general, when it reports, it also sends information about, hey, this replica which belongs to this partition belongs to this service, and this service has this service type, and this application has this application type, and so on. So we are able, and this replica lives on this node, so we are able to build a hierarchy.
Great.
Then when we evaluate, so first of all, how does this information reaches HM? So we have a health client that sends reports to HM. So there is a sync API add report. This one puts the reports in a queue, and periodically the health client sends them to HM. And if one of the reports does not succeed, it will retry. So the whoever puts the report inside the health client doesn't need to worry about it. It will retry internally.
Okay.
But that means that when you add the report, if this succeeds, that doesn't mean the report will succeed eventually because it may fail. We have stalemate detection, for example. We use a sequence number. And if the health client puts the same sequence number, it will fail, right? Because it's already there. So this health client now can live inside a Fabric client. So anyone can report through Fabric client. I could have my watchdog. Let's say that watchdog is another service in the same application as your service that you want to look at.
Okay.
And you could say, I have these conditions. I'm going to evaluate. If something goes bad, I will report. Or you can have your service itself reporting. I've tried to do something, I cannot. I'm really in a bad state here. Or you can have someone outside the cluster. Let's say that the user expects 2.whatever milliseconds latency and it has more. So it would say, hey, these many requests were bad, so there's something wrong with the app.
And then it signals to the health manager to evaluate it?
Well,
And do something about it?
The evaluation does not happen when reports are persisted. When reports come in, HM just persists the information.
Okay.
Then whenever somebody who is interested of the health, then we evaluate.
Okay.
And that's the part that I was coming to. The reason we do that on a request is because we use health policies to evaluate. And when we evaluate an entity and all of its children, if it has it, right? So if you say, hey, is my application healthy? This application will have some health events on it, so we evaluate that. But it also has some children, and we evaluate everything, right? So this way, if the replica here is bad, so there's an error report here, this will surface into the application health. So application will be in error because one replica is in error.
Got it. And that'll show up in SFX.
Yes.
And that's what we're seeing when we look at the diagnostics inside of SFX, which is Service Fabric Explorer.
Yes.
The UI people see.
Yeah.
Right on.
That's the thing I was mentioning here.
Absolutely.
Okay. Yeah,
Good.
That's about it.
That's about it.
Yeah.
Okay,
And
but
then
there's a
for
lot of things.
For evaluation, we use these health policies. For example, you say, how many replicas can I tolerate to be unhealthy? So it marks % unhealthy replicas. Here we'll have how many Partitions can I tolerate to be unhealthy, max percent unhealthy partitions, and so on. So for example, in SQL clusters, they have a gazillion of nodes. Out of those nodes, a pretty good number will be in HI, human intervention, right? So those nodes will be unhealthy. So actually when I evaluate the cluster health, they will say, I tolerate 20% unhealthy nodes. So if that's, we know that that's going to be unhealthy, right? But the cluster will not appear as in error, it will appear as in warning.
Okay.
Because I can tolerate that. Something is wrong, because we have errors, but I can tolerate it, so it's in warning.
So that actually leads to an interesting question. I mean, how does one know what they can tolerate? It's one thing for like SQL Server types to know what they can tolerate using us underneath them. I mean, they have a deep understanding of distributed systems. But for like people who want to use Service Fabric and they're creating their cluster and stuff, how do they know like what's a safe percentage of unhealthiness?
0%.
0%. Amen. All right. So what if I tell you 0%?
That means you can't tolerate failures.
I want to be completely fault tolerant.
Yeah, 0% is fine, because if something is fishy in the system, we will report as warning. And those warnings do not impact upgrades. Only errors impact upgrades.
Okay.
So that's why the percentage is useful, because if you have 20% of nodes in error, you can still do an upgrade, cluster upgrade.
Interesting.
Right?
Okay.
That's the whole point. Now, here's another thing. It's an important question. How is health used? So one usage I mentioned already is the upgrades, right? You do a cluster upgrade, you do an application upgrade, and you want to roll back. Other than that, do we do any fixing? Something is bad in health, do we fix it?
Yes.
No.
You don't?
We don't.
So you're not like our health system in our bodies.
Okay. Well, so we have some system components that do some repairs. For example, on the node, we know that an infrastructure service will say it's really bad, then the node will be restarted. Okay. But usually we don't. The way we have it set up right now for our internal clusters, we have alerting. So if the cluster is in error for 30 minutes or whatever warning we cannot possibly tolerate for one amount of time, then we issue an alert. And based on that alert, we actually have incidents coming to us directly. So you will have an incident say, cluster was unhealthy for this amount of time, figure it out. And this is how we take actions, basically. Okay. Now, there are systems that could take action based on this, right? But mostly it's used for just looking at SFX. You have a problem, you look there and figure out what's wrong, right? You cannot create a service or whatever happens, and you see that the CM is unhealthy, right? And then you figure out why is that unhealthy. You fix that, and then you can create your service.
Cool.
And so you basically use it in SFX to see that. You're using for alerting. Most people do some kind of alerting on top of health to get the most benefit out of it. And we did have the repair manager system service. Not exactly sure what happened to it. I think it's deployed in some internal clusters, but it's not the way to go. Okay.
But I mean, you've empowered developers to, query the system or to be alerted from the system when things go bad. And then I can say, okay, if I reach this threshold, so if I reach 20% failure state or whatever, 20% of my replicas have failed or quorum loss is happening at some percentage, then I can say, okay, here's how I'm going to handle it. And I'm given that control, right, as the owner of the cluster. And so you have people that are actually, that's how they deal with health management on the other side. Cool. So what happens if the health manager gets unhealthy? What's monitoring the health manager?
Well, that's a good question, right? If the health manager can expose his data, you will see it as an error on the cluster manager service, right? If it's really bad and the CM is down, then your cluster is probably in a horrible state.
Understood.
And over the years, I only had 2 incidents like this. I had an incident where I stayed out for 2 nights.
Wow.
Because they put on the cluster too much load.
Okay.
And basically the system component, everything in the cluster was like on its knees. So we actually had to go on the nodes and a lot of manual mitigations and things like that. So this is like 12 years, or just 2 incidents like that, most of the time this does not happen. Sure. You will not see it. They will be responsive.
Sure, as long as there's CPU and memory.
Yeah, so most of the system services are designed to tolerate many conditions, and we've improved that based on the incidents we had. So we changed throttling, for example, right? Because there are many reports that may come into HM and may be overloaded. So at one point, it has a queue, it reaches the max that it can keep, it will say, hey, I'm too busy right now. And the health client knows to not put more pressure. When I get service too busy, the health client will say, I'm exponentially going to retry this, right? So as long as it keeps getting servers too busy, it will slow down until it gets okay, and then we'll continue to send.
How tapped in is the health manager to sort of the user code that's running inside of one of these processes?
So they can. So first of all, the system components know about the service. So for example, if run async fails with an exception, you will have a health report saying run async failed with this exception, and here's the exception. So they can get that, but they can also report themselves, right? So from within a service, you can report on your application only. So you can do it through partition object or the code package activation context, right? So you get that partition object and say report health, report instance health, or report replica health, partition health, or whatever it is. So that is the preferred way to report from within the service, because you are limited to only your service, and you can do it regardless of what privileges you're running with. From Fabric client, though, you can report on all of entities, which means you must have privileges to do it. Right? Because you don't want app A to screw up B because I don't like it that much. So we have a priority for each of the reports, and the system reports have higher priority. So the authority reports have the highest one, and then the other system reports, and then there are the user reports. Okay.
Now, of course, all of this happens obviously asynchronously and in a highly performant way. You don't want to impact the behavior of the service that you're monitoring.
Yeah, that's why we actually decided to have this add report sync, which means I put the health report in the health client, but I don't dictate it when to send it over the wire. Because let's say the health reporting was intended initially for periodic reporting, which means I don't have much state. I'm a dumb watchdog. I just have this condition that I'm looking at. And if that condition is not true, I'm going to report error or warning or whatever it matches the intent. And otherwise, I'm just report okay to say that everything is fine, right? So then you will say every, let's say, 30 seconds, you will evaluate your condition and say add report, add report, add report, add report. And you may have okay, and so on. And this you will have an error. Right? So if you add many of these reports and you send them over the wire one by one, you will kind of sort of bring the system to its knees, right? So you don't want that. Instead, the health client will have a window of time that it collects all the reports and then it sends them in one message. So we don't have 1,000 messages for 1,000 of reports. We have only 2 messages because we batch.
Okay. And what about preserving disk space? So the replicator truncates and stores like 64-bit numbers.
So that's another thing. The health subsystem does not have historical data. So if you look in SFX, you will see that there's one event, right? So let's say that we have a replica here, and then we have a report from it from system.array, state, and arrays, of course, array, state, and whatever other information, right? So if array reports again, we will override this guy. Because the primary key, if you want to think of as the store underneath, the primary key for the health event is the entity ID plus the source ID, which is in this case system.fn. So basically who reports it, system.array, and then the property on which you report, which in this case is state, right? So as long as you send the same, I will just replace it.
Okay.
So you lose the state of the previous one, and you just have the latest.
Okay.
We have a bunch of optimizations like this. So for example, for periodic reporting, if you send the same, okay, every single time, we don't persist it.
Okay.
We just keep the the one that we persist, and then we keep in memory saying, okay, but the last one is actually this.
Okay.
So we do a bunch of optimization, and we only persist when something changes. So this way we just save some transactions.
Got it. So yeah, so if you persist when things changes, then I can actually see sort of the flow of what happened.
No, you will not have any history.
No history at all.
No history at all. So for the history, we have something in the working. We have another service that will be able to pick up these events, and it can also expose them. So you can query through REST, like give me the events, and it can also, it keeps them, so it will give you the history. So that's in the making. We don't have it exposed right now, but it's gonna come. Cool. The REST API for the events, I think, are already in 6.2. So
6.2 being the latest one we released. That was, I know you worked really hard on. Everybody was. You guys, I mean, you were all heads down, cranking.
Everybody is all the time.
When are you
right?
not cranking? But it's fun though, right?
Yeah.
These are really hard and interesting problems.
Yeah.
Of distributed systems. So, I mean, okay, so I think people probably have a pretty good understanding of like the basics of health management.
Just to be clear, these are very basics. We have many more things inside, like the hierarchy and the way we clean up. And
can we crack into one of those or two of those, or?
It depends how deep you want to go. Another thing that we have that users don't really care about, that is just internals, if you want to.
Internals are great.
I have a sequence streaming algorithm.
Okay.
So, like I said, most of the times people report periodically, which means they don't care about what's in health, right? I mean, I'm just reporting on what I have right now. But if you want to report and you want to persist a certain sequence number that you have and you want that sequence number to be in health, then you want the two to be in sync, your reporter and what health has.
Okay.
So, for example, this is what FM is doing. System.fm, the failover manager system. So FM is the authority for partitions, for services, and nodes. Okay, so it has its own sequence number. So whenever something changes, it generates, for example, there's a movement and it generates a new configuration for a partition. It has a number, it increments, and that number means something. So it stamps the report with that number. Now, what happens when FM goes down and HM goes down? What if HM has information from FM, FM went down, came up and lost that data, right? So they go out of sync. So then we have a sequence streaming algorithm that keeps them in sync. So the FM will ask HM, where are you? And HM will tell him, here I am. And if FM doesn't like the number, says, scratch that. You should be here.
Nice.
Right? And then FM sends the data that is of actuality, and then HM prunes all the other information.
Awesome. And how effective is that? It's like 100% effective?
Yes, we've never had it. I mean, we've tested this. The rebuild, this happens when the FM rebuilds, so FM loses data. It's a very rare situation, but we've tested it and it works just fine.
That's great.
So the sequence streaming is basically for each source, like in system FM, and for each entity type. For example, system FM and node, it will have one sequence streaming, which means we do not affect any reports sent by anybody else or reports sent by FM for another entity type. So it's very specific to that stream.
Excellent.
Yeah.
So in terms of the hierarchy of components and subsystems, so what other subsystem components rely and interoperate with the health manager?
The cluster manager is the one that we actually have an internal interface between them because they really need each other.
Sure, I understand.
So during upgrades, actually let's talk a bit about evaluation. I mentioned previously that anyone can query, give me the health of your application, give me the health of the replica.
Yep.
It's the same one that appears here in SFX. So when you query the cluster health, right? So this guy over here. Basically, we evaluate everything under the cluster. All the entities, we know whether they're healthy or not, and then we propagate their information for the cluster. Now, what CM does during upgrade is more advanced. So we do the exact same all evaluation, but on top of that, the way upgrades work, they're UD by UD, upgrade domain by upgrade domain. So let's say you have an UD, next UD, so this one has some nodes, right? So the upgrade will go first in this UD, right? It will move replicas, do what needs to be done, upgrade. And then CM will check health here. And we have a bunch of health configurations for the upgrade. Like how much time do we need to wait before starting health checks, how much we retry if something is wrong, how much do we wait to be stable before we consider that it's all healthy, right? So during this health evaluation, CM calls into cluster, I'm talking about a cluster upgrade, but it's the same for application. So CM updates the cluster, but on top of this global evaluation, it does per UD, as in it takes all the nodes, figures out in which UD they are, and they do evaluations. And you can say, hey, for this UD, I do not tolerate more than whatever degradation.
Okay.
So if more than one node than it was initially goes down, I consider belly up. So you roll back. So you have delta per UDs, you have delta per the whole system. So these are only done when CM wants to evaluate health during upgrades. Other than that, when you do evaluate me and an entity, we don't do the per UD thing.
Okay. But I mean, clearly you'd want to make sure that the system is healthy after an upgrade has taken place. Yeah. So that totally makes sense.
Yeah.
And so if it's not healthy because it's all really transactional, you roll everything back to the last known good state.
Yeah, so we do the health here, and if everything checks, we move on to the next UD, and then we compute health here again, and so on until at the end. And if anything of this doesn't turn out to be healthy, we roll back. So during an upgrade of application or cluster, there are multiple components involved. It's the FM that moves the replicas and makes sure that that you have the quorum up and running for any service, so that you don't get any availability loss. And so this happens while you walk this UD, while you go through all these nodes in this UD. So you have the safety checks, and this one are performed by FM. And if any of these safety checks cannot be met, you're stuck. You're sitting there until you can meet the safety checks. So, for example, let's say that it takes some time. You have a big replica with gigabytes of data, and you need to move it somewhere else. It will take some time, right? Yeah. You will stay here until it moves all the data, and you don't lose availability, right? Because you are waiting for it.
Understood.
So that's the FM's job. Then CM is the one that works with HM to figure out the health, and they move forward together.
Great. And so let's talk a little bit more about where you can, because we're open source now, but we're still working on things that we haven't talked about. They're sort of not necessarily the same thing yet. Yeah. What are some of the things that you're working on? You mentioned you're going to be able to do historical analysis over health data. What else?
For health, we don't have major work coming in.
Okay.
We have some remaining work, some improvements in upgrades, for example. Like I said, we have Delta for cluster, but we don't have Delta for applications. So that's one feature that we're looking into. And there are a bunch of other things. So, for example, in the way we expose what's wrong in the cluster. So you will go to the application, and you have the unhealthy evaluations, and that points to the first thing that was wrong in the cluster, right? Because you want to get a glance at what happens, and that will be a hierarchical view. So you say, my application is unhealthy because 20% of the services are unhealthy, and here are the 20% unhealthy services, and here why they are unhealthy. Well, this partition, this replica has an error, right? So you get all that information hierarchical in SFX. That works pretty well, but not always. Because, for example, FM knows when a partition is below replica. It expects to have 5 and it only has 3. So it says, hey, warning, this partition is below replica, right? It does not know why, but it has this warning. So in SFX, you will see in the healthy evaluation is because the partition is below replica. And people are like, why? And the answer is you need to go dig it up. Because we usually, we stop at the first reason, but you can go then in the partition itself and you look at the events on the partition, and then you look at the replicas and you will see what events they have. And then maybe they can shed some light. But the question is, can we be smarter? can we identify, okay, the partition is below target, but can I give the user something more useful? Like, hey, go look at this replica. It's not coming up. You have a bug in whatever open code or whatever it is, right?
Yes.
So if we can help people with this, I think that would be a great feature to have. Unfortunately, this has been on the back burner for a while. We have improvements coming all the time in the way we report. So for example, in, I don't know, like 2 or 3 or 4 releases back, hosting was reporting that there's an error during activation. And I had a zillion of questions from people, what does it mean? Well, you need to look in the event log and figure out if you have something related to your service and see why it doesn't activate. And it was pretty painful. So we changed a lot of that. We improved the reporting to say exactly why. Well, you cannot find a certificate or whatever it is. So there are still cases where it's opaque because we don't know, right?
Sure.
But we've done a lot to improve, like, what's going on. Give the user something that he can run with.
Okay, so I've spent a fair amount of time in the tracing code.
Okay.
And there's a lot of tracing that goes down. But you don't necessarily know. You're just writing things out. So you're saying you're adding more intelligence to...
So that's not for tracing. That's for SFX. Right?
Okay, got it.
Most of users we tell don't go to tracing. You will be completely... right?
Fair enough.
It's a lot, right?
It's a lot. It's a lot.
So if they look at all of our traces, they will not know what to do with them.
Of course.
It's like gigabytes and
It's
gigabytes.
for us.
Yes. We have some important traces that we put in another channel that they can look at and they can get some information from that. That's a good place. But wouldn't be easier if somebody tells me exactly what's wrong and I wouldn't have to search?
Amen, yes.
Yeah, so that's the work. It's like, can we be smart enough to tell you what's wrong?
So that kind of goes back to what my question I was trying to ask was, so when you write out things to a log file or you write out to events or you write out to traces or text files or whatever, you just write out. Like, I have this information and this is what it is and this is the time and blah, blah, blah. But so what you're saying is you're going to put some smarts in front of that. Yeah. And you'll be able to say, hey.
So you will still have the raw information, but we want to be able to tell you what's wrong. Like with a high degree of confidence.
Understood. So is that machine learning? Is there going to be some machine learning going on? Because there's so much data.
So like I said, this feature has been on the back burner for a while. Unfortunately, we have too much conflicting work. So when we get to this, we'll figure out how to do it. But we have some, basically it's going to be some correlation between, hey, if, for example, for the case that I said that the partition is below target, why is it below target? Well, you know, if the replica crashes, we can look at the array and point you to the array report rather than the FM report, right? Go down at that level. Or if this hosting that reports some kind of error on that node, we will point you to the hosting one saying, hey, I cannot download the code or I'm missing a DLL or whatever it is, right?
Awesome. That'll be great. I mean, there's so many moving pieces here. It's going to be really interesting.
I know. It's a big piece of work, but I have no promise.
Yeah, no promises, but I mean, it's a great engineering challenge.
Yeah, I know, right?
With amazing benefits for customers.
I know.
So everybody will jump in.
So, and then I told you that Vipin is actually working on the other service that exposes the historical health and is able to do some analysis on it. So I recommend you can talk to him.
Vipin. Absolutely. And we'll talk to AP on FM.
I think you'll probably talk on failover, but mostly towards array reconfiguration engine. Okay. Mansoor is FM.
Mansoor is FM. Man. AP, FM. Yeah, it's hard to get it all straight. At least I know they're all in the same pod, right?
Yes, they are.
So I got that right.
Pod. Yeah.
Right on. So you mentioned the sequence streaming algorithm. Algorithms are like this. Service Fabric is a garden of algorithms, right?
Know,
Advanced distributed system algorithms. Distributed computing algorithms.
Yeah.
So that's actually could be a series in and of itself. So what's your favorite algorithm that you've developed? How's that for a question?
I think in health, I kind of like the job queue manager and the way we So basically, we have a bunch of entities and a lot of work coming in, and we want to not use too much threads, and we want to throttle when necessary and don't bring the system to its knees. So we have this job queue manager that is able to say, hey, for this entity, only one job is running at a time. And then for that job, is smart enough to take multiple reports and bring them together if it can. So it can persist them in a single transaction to make it more performant. So all that, it's pretty complex in job queue manager the way it's done.
Cool.
And we have a bunch of, the distributed system is like, when do you persist? So, you take the data, you make some, you keep something in the memory to know that you are changing some, you go to the disk and you write it, and only after it's replicated you can move the pending data to the actual end state. So that's something that we're using all over.
Awesome. And that involves getting a signal from a replicator that you're able to move forward.
Yeah, so like I said, it's a system service. You're using underneath service fabric services, no magic. We're using our own thing, right?
Yeah.
So and basically just create transactions when those come back. And another thing we're using here is a simple transaction instead of the normal transaction. And the simple transaction basically batches a bunch of transactions that are pretty small, up to you can configure it how much memory or how many small transactions you can have. And then you commit this batch, and of course it's much faster than if you would commit one by one. And then they either commit together or they will fail. So if they fail, it's pretty going to affect more.
Sure.
But it's still, the performance was much better with that than before.
Great. And it's impressive how performant the actual whole system is in reality, right? There's a lot of code that's running at any given time.
Yeah, I think what we've learned, what we've modified more is mostly the throttling. And basically, if you have a lot of load, because we had problems, for example, where we have instance, like the replicas, the stateless replicas, the stateless instance, they were crashing all the time. So we had, for example, the demo for the 1 million containers.
Yeah.
And we put, by mistake, a package with one of these instances that crashed all the time. Well, guess what? Array was reporting on each of those instances, it's crashing. Delete this, it's crashing, let me create a new one. So it was in the loop, crash delete on all the nodes, right? So you can imagine how much load HM was receiving at that point in time.
Sure.
So 1 million containers, that means I don't even remember how many replicas, but much more than that, right? And then all of them down, up, and down, and up, and down, and up, and down, and up, and down.
And it was handling it.
Well, it was handling it till it wasn't handling, and then it was rejecting everything.
Okay.
Right, and then the whole thing that you will see that you have stale information. Well, duh, I cannot.
Sure.
Right, so then it was rejecting it, but then the health client was sending it again with the exponential delay. So eventually it will have caught up, but we've learned a lot, right? Because at the beginning we could not handle it. So we added all the throttling based on all this experience that we had.
Great.
So at the beginning we're like, yeah, sure, we receive a lot, and we cannot do anymore, sorry.
Well, yeah, I think the 1 million containers thing was a fun demo. Yeah. It's certainly indicative of the capabilities, but it's not necessarily realistic for an 1 million.
So that one was
container
mostly
cluster.
Just demo-wise. I know.
Pretty impressive. World record.
It was a very good test for the system components to handle this load, not just HM, but everybody, because there were a lot of entities created, right?
Interesting.
So that was a good load for a good test load.
Do you still use? So that actually brings up a great point. I mean, we have hundreds and hundreds of tests. That might be like a good test, like a stress test where you have to.
We do have like a small scale. We have this kind of test. We have a perf and a scale. For basically each component has it. For the health, we have a test that sends a lot of reports and busts them in, and then deletes them and makes sure HM can handle that.
Cool.
And then we evaluate how long it takes, and if there are regressions, we're able to detect that, hey, it takes longer now than before.
Great. So now I think people know they can put a face to and some architectural drawings on the whiteboard to what they look at in SFX with respect to health.
Yep.
and the health of their cluster, and the things that go in to ensure a healthy cluster. An unhealthy cluster doesn't last too long.
Yep.
Right?
Yep.
Hey, thank you so much for taking your time. I know you're cranking.
Thank you.
And hopefully we'll talk to you again. In fact, we will, because I want to learn more about Image Store
Sounds good.
and some other stuff. So thank you very much.
Thank you.
Cheers.